Hi students, I am Prashant B. Chandran, Assistant Professor Automobile Engineer Department SN8 Adur. Welcome to my new video, and this video is about a problem from transient heat conduction. That is problem number 7. Okay, welcome to the problem. The problem is a long steel cylinder of 12 centimeter diameter, initially at 20 degrees centigrade, is placed in a furnace at 820 degrees centigrade with H is equal to 140 watt per meter square Kelvin. Calculate A. Time required for the axis to reach 800 degrees centigrade. B. The corresponding temperature at a radius of 5.4 centimeter at same time. Take K is equal to 21 watt per meter Kelvin, alpha is equal to 6.11 into 10 raised to minus 6 meter square per second, rho is equal to 7,833 kilogram per meter cube, C is equal to 465 joule per kilogram Kelvin. Okay, this is the question. In the question itself, it is clearly given that it is a cylinder and its diameter 12 centimeter, initially at a temperature of 20 degree, that is Ti is given, and a furnace, that is at 820 degree means T alpha is 820 degree, and H is given. We have to find out time required to reach 800 degrees centigrade and corresponding temperature at a radius of 5.4 centimeter, and the values for K, alpha, rho and C are given. Okay. This we are writing the given data. Okay, it is cylinder diameter 12 centimeter, that is 0.22 meter, therefore radius 0.06 meter, Ta is 20 degrees centigrade, T alpha 820 degrees centigrade, K H is 140 watt per meter square Kelvin, K is equal to 21 watt per meter Kelvin, alpha 6.11 10 raised to minus 6 meter square per second, its density is 7,833 kilogram per meter cube. So it is given as C is equal to 465 joule per kilogram Kelvin. Okay. And to find, we have to find out two things. The first one is time required for the axis to reach 800 degrees centigrade. The 800 degrees centigrade samyam, that is tau. We have to find out tau when T is equal to 800 degrees centigrade. T is equal to T0 is equal to 800 degrees centigrade. Then second one is temperature at a radius of 5.4 centimeter. Radius of 5.4 centimeter. 5.4 centimeter we have to convert it into meter, that is 0.054 centimeter. So meter. That is, we have to find out the temperature Tr when radius is equal to 5.4 centimeter, that is 0.0454 meter. Then solution. First of all, we have to find out the LC, it is characteristic length. That is, LC for a cylinder is given by the equation LC is equal to radius divided by 2. Radius divided by 2, that is, here the radius is R0 divided by 2. R0 is 0.06 divided by 2. That is, we get LC is equal to 0.03 meter. Okay. After finding LC, we can directly find out Biot number BA. You know that Biot number BA is equal to HLC by K. That is, H value, it's given the problem, that is 140 into LC 0.03 divided by K is also given as 21. It is Biot number BA is equal to 0.2, okay, which is greater than 0.1. And Biot number value is greater than 0.1 and less than 100, then it is infinite solid. Infinite solid. Okay. The Biot number value is greater than 0.1 and less than 100, then it is termed as an infinite solid. Okay. It is from for cylinders from HMT data book page number 69. A graph is there. Regarding this graph, x-axis is alpha tau by r0 square and the curve is h r0 by k, and y-axis is t0 minus t alpha divided by ta minus t alpha. We have to first find out the value for x-axis alpha tau by r0 square, but we don't know the value for tau. Okay. Alpha value is 6.11 into 10 raised to minus 6 into tau divided by r0 value 0.06 the whole square. We don't know the value for tau. Next, we have to find out the value for HR0 by K, because we don't know the value for tau. It is a question. So the next option is we have to find out HR0 by K. That is H value. We know that the value for H is 140 into R0.06 divided by K value 21. We get 0.04. That is the curve is 0.4. And T0 minus T alpha divided by Ta minus T alpha, that is y-axis value. We are substituting the values, we get T0 value 800 minus T alpha is 820 divided by Ti, initial temperature is 20 degree. Initial temperature 20 degree minus T alpha is 800 degree. Therefore, we get the value for y-axis as 0.025. Then for y-axis 0.2025, and that line touches the curve HR0 by K is equal to 0.4. We get alpha tau by R0 square is equal to 6 from the graph. Okay. It is we start from y-axis, and this y-axis value from the graph. For y-axis value, that is T0 minus T alpha by Ta minus T alpha is equal to 0.025, and this line, when we extend that line, it will touch the curve, that is HR0 by K is equal to 0.4 curve. From that point, we have to extend that line towards the y-axis. We get alpha tau by R0 square is equal to 0.6. Okay. We get the value alpha tau by R0 square is equal to alpha tau divided by R0 square is equal to 6. We get it from the graph. Then substitute the value, that is alpha is equal to 6.110 raised to minus 6 into tau divided by R0 means the value for R0 is 0.06 square, and the square is equal to 6. From that we get tau value as 3535.188 seconds. This is the solution for the first part of this question. Okay. Then the second part is temperature at a radius of 5.4 centimeter. Okay. from our HMT data book, page number 70. There is another graph given. From the HMT data book, page number 70, another graph is given, which is of which this is the x-axis and this is the y-axis. That graph, x-axis r by r0, and the curve is the same, that is hr0 by k, and the y-axis is given as Tr minus T alpha divided by T0 minus T alpha. Okay. We have to find out the value for r by r0. R is given as 5.4 centimeter, that is 0.054 meter, divided by r0. We know that the value is 0.06, and we get r by r0 is equal to 0.9. Okay, and hr0 by k we have already found out the value as 0.4. Okay, we get Tr minus T alpha divided by T0 minus T alpha is equal to 0.85 from the graph. Okay, this we get the value Tr minus T alpha divided by T0 minus T alpha is equal to 0.85 from the graph. For the corresponding values of r by r0 is equal to 0.9 and hr0 by k is equal to 0.4. This Tr minus T alpha divided by T0 minus T alpha is equal to 0.85. Substituting the values, Tr is the only unknown. Tr minus T alpha value is 820 and T0 is 800 minus T alpha 820 is equal to 0.85. Cross multiplying, we get Tr minus 820 is equal to 0.85 into 800 minus 820. From that we get Tr is equal to 803 degrees centigrade. This is the answer. Okay. That is we get temperature at the radius of 5.4 centimeter is Tr is equal to 803 degrees centigrade. This is the answer.